So welcome to this segment of my physics videos as I give you a summary on making ammonia, some few points that you need to carry out. If you remember, N2 plus H2, a reversible reaction to produce the ammonia, and you balance it up in that way. And remember what we did say when it comes to that. We did say that the forward reaction is simply an exothermic reaction and the backward reaction is an endothermic reaction. So if you look at the number of molecules that you have, in front of the nitrogen you have 1 plus these 3, so meaning that there are 4 molecules. There are 4 molecules of that you have on your left hand side. Then on the right hand side, the coefficient of ammonia is a 2, meaning that you have got 2 molecules on the right hand side. Now if that is the case, what can you do to improve the yield of NH3, to improve the yield of ammonia? So one, in order for you to improve the yield of ammonia, you need to use a quite high temperature. So you need to use a quite high temperature, and that's what we talked about, 450 degrees Celsius. 2, you need, from this one, according to La Chateria principle, so if you want more ammonia to be produced, it simply means that you can remove more ammonia so that it favors the forward reaction. So you can simply say, remove ammonia. So when you remove ammonia, it simply means that it is going to favor the forward reaction. In this case, the exothermic reaction will be favored. Okay, another thing that we can talk about is suppose one wants to get a, maybe we can say, a decent reaction rate. So if you want to get a decent reaction rate, it simply means that one, you can use a moderate temperature. If you just want to get a decent reaction rate, so you can use a moderate temperature. That can help. Then 2, you can also use a catalyst. So that is what you need to remember. And previously I did talk about fertilizers, and fertilizers. And among the fertilizers that I talked about, ammonium sulfate, ammonium nitrate, and I also did talk about ammonium phosphate. So those are the fertilizers that we talked about. Now the question is that we can briefly look at is that maybe we can say that ammonium nitrate, so we can say that ammonium nitrate is rich in nitrogen. So it is actually rich in nitrogen. In the exam they can tell you to say what percentage of it is nitrogen. So let's try to see how we can find what percentage of it is nitrate. Remember, ammonium nitrate is NH4NO3. So what you need to do is you need to find the mister of this compound. So you need to find the mister of this compound. How many nitrogens do you have in the compound? So if you look at the nitrogens, this and that, so it will be 2 times the atomic mass, which is 14, plus how many hydrogen do you have in the compound? There are 4 times 1, plus how many oxygen do you have? There are 3 times 16. So that is going to give me 28. This is for nitrogen, this is for hydrogen, and that is for oxygen. Plus a 4 plus that is a 48. When we add all that stuff, it is simply going to give us 80. So if you want to know the percentage of nitrogen in the compound ammonium nitrate, you consider the total mass of nitrogen in the compound. Remember this and that gives us a total mass of 28. So it will be 28 over the total mister in this case, which is 80. Then you multiply by 100%. So when you use your calculator there, you are going to find that it is going to give you 35%. So that is the percentage of nitrogen in the ammonium nitrate. So that is what you need to remember. I have another question, examination question that came, which you can simply look at. Very important question. Please pay attention so that you are able to benefit. So it says the substance below shows some of the properties and reactions of aqueous ammonia. So they're telling you reactions of aqueous ammonia and some other substances that they are talking about. All right. And then it says that so this is a reaction scheme that they have given you. So it's very important that you get to have a lot of ideas about chemical reaction and their properties. So they say colorless acid solution. So this is an acid that we're having there. So that's an acid A. They're telling us when it reacts with aqueous barium nitrate, it produces a white precipitate. At the same time, when this acid reacts with aqueous ammonia, it produces a white salt. But when this white salt reacts with aqueous sodium hydroxide, it produces a colorless gas. Obviously, because this is aqueous ammonia that we are involving, the gas that should be produced definitely should be ammonia gas. But let's try to look at the A part there. The A part there says that identify by name. So I want you to identify by name the substances A, B, C, and D. So A, obviously, if you analyze, in order to produce a white salt and to produce a white precipitate when it reacts with barium nitrate, obviously this acid should have actually been sulfuric acid. So that should have been sulfuric acid. Alright, so that should have been sulfuric acid. That is what we mean. And then B, what could be? So when sulfuric acid reacts with barium nitrate, the white precipitate that is formed is simply barium sulfate. Remember when you did your acid, bases, and salts, I'm sure you are able to relate to that. So barium sulfate is, or B, what is going to be produced there. Then C, when that sulfuric acid reacts with aqueous ammonia. So remember what we said, when an acid, the sulfuric acid reacts with aqueous ammonia, that is going to produce what we are calling as being ammonium sulfate. So it is going to produce ammonium sulfate is going to be produced. All right. So ammonium sulfate in this case, so ammonium sulfate that is going to be produced. Then what is our D? So meaning, since C is ammonium sulfate, remember we said when any ammonium salt reacts with a base, an alkali, it produces a gas, and that gas is what we call as being ammonia. So when this ammonium compound reacts with an alkali, the gas that is produced is ammonia, NH3. So that is what you need to remember. So that is the identity of the substance labeled A, B, C, and D. Now let's move on and look at the B part. So the B part is simply telling us to say write an ionic equation including symbols for the reaction of A with barium nitrate to form B. So remember we said we did mention that here we do have this is sulfuric acid, and what is going to be produced there is barium sulfate. Here we have what we are calling as being ammonium sulfate, and there we have NH3, that is ammonia gas that is produced. So they want us to write an ionic equation where A reacts with barium nitrate. Now of course, from the acid you are going to find that from the acid you are going to get hydrogen ions, but since you are producing barium sulfate, that's a precipitate, so you just need to focus on that. So it's like the reaction that will be taking place if you write your ionic equation. You focus on the product. What are the two ions that are making up the salt? It's barium and sulfate. Therefore the ionic equation should have been barium, remember, has a valence of 2, so 2 plus, that is in aqueous, reacting with the sulfate ion, which is still in aqueous, to produce barium sulfate, and barium sulfate is in a precipitate, so we're going to use the state symbol S for solid. The other one that we are producing is when this acid reacts with the compound ammonium sulfate. Now when it reacts with ammonium sulfate again, so you are going to focus. Remember, at the same time you are going to find that water is actually going to be produced. That's the main product that you are going to have. So the overall reaction that will take place is going to be hydrogen ions that are in aqueous plus hydroxide ions that are in aqueous will form up what we are calling as H2O. Remember, sulfuric acid plus that one plus ammonia solution, we are going to have ammonium sulfate, but water is going to be given out in the process, and that is the ionic equation that we are going to have. C says when C reacts with aqueous sodium hydroxide. Of course, remember, when any ammonium compound react with an alkalis, a salt, ammonia and water is also going to be produced. So the overall reaction is that you are going to have ammonium ions which are in aqueous. Those are going to react with hydroxide ions which are in aqueous coming from the base. Remember, this ion is coming from that salt that we're having. So now when these two react, you are going to find that H2O in liquid form is produced, but at the same time ammonia gas is going to be liberated. So these are the ionic equations that they wanted you to write there in this exam. Then C there says name a method you'd use to collect gas. We have talked about so many times about ammonia. How is ammonia collected? So you can use what we call the downward displacement. So you can use the downward displacement of air. So downward displacement of air is the method that is going to be used. Thank you so much for watching my videos, and sorry for my voice appears not to be okay, so watch out for my next videos.